Hello everyone and happy Tuesday. I hope you guys had a fantastic rest of your day on Monday. I hope you guys are being amazing for the sub. Please say you are. She is very sweet. We are now looking at example 1. We are on lesson 7-6 and it is labeled find probabilities of compound events. So the first example I want you guys to look at is example 1. It says, find the probability of compound events using a table. Sadie has 1 ticket left at the school fair and she hasn't yet won a prize. She decides between 2 games which she should play. She has a game called Flip to Win, where you flip 2 heads to win a prize out of 2 quarters, or she has Flip and Spin, where she has to flip a head and spin a blue. So we need to figure out which one gives us the greatest probability of winning. So first of all, I have Flip to Win. If I have quarter 1, let's make, I'm going to do it down here. If I use my quarter 1 can land on either heads or tails, correct? Yes, Miss Delsby, that's correct. I miss you guys. My quarter 2, if it lands on heads, it could either land on heads or tails. And if it lands on tails, it could either land on heads or tails. That gives me 4 different outcomes. So this is just like what we did yesterday. To figure out what my denominator is going to be, I do 2 times 2. 2 times 2 gives me my denominator of 4. Now I need to figure out how many of those 4 give me, I'm flipping heads 2 times. This one is heads, heads. That one works. Heads, tails, nope. Tails, heads, nope. Tails, tails, nope. So how many times? 1/4, or 25% of the time, I have a likelihood of winning this game. Now let's look at Flip and Spin. We are having a quarter first. My quarter, let's write, I can either go heads or tails on my quarter. If I land on heads, I have 4 different options of what I could spin. I could spin red, yellow, green, or blue. If I land on tails, I also have 4 different options of what I could spin. Red, yellow, green, blue. So that gives me my total, or I could have done 2 times 4. My total outcome, my denominator, is going to be out of 8. Now I need to figure out my outcome of flipping a heads and spinning blue. So flipping heads is only this. That eliminates this entire thing. How many times could I land on blue? Red, no. Yellow, no. Green, no. Blue, yes. Only this one time works. Oh, I meant to put that there. And 1/8 is 12.5%. So, I mean, I don't know about you guys, but if I was playing this, I would definitely pick to do the Flip to Win, because I have a 25% chance of winning versus the Flip and Spin gives me a 12.5% chance of winning. Okay, now I want you guys to look at your try it. So either pause it or just wait, and we are going to solve this. Okay, hopefully you guys solved it. So now the designer of Flip and Spin creates a new game using a 5-section spinner. Now there are 5 different sections. How does the new spinner change the probability of winning a prize? Well, first of all, if I do my 2 times my 5, my denominator is out of 10. And I need to, number 1, using the 5-section spinner, the probability of winning a prize is something over 10. I would have to flip the heads, and now I need it to land on blue, but I have 5 different options. I only have 1 time that I will flip heads and land on blue, so that gives me a 1 out of 10 chance. It is less likely. Hopefully that is what you got before you moved on. Let's look at example 2. It gives me my tree diagram that I've been making with you. What is the probability that a coin flipped 3 times will land heads up exactly 2 times? So if I start with heads, and tails. That's what they did. Heads and tails. I'm just drawing the tree diagram right now. Heads, tails, heads, tails, heads, tails, and heads, tails. I want to figure out the amount of times that it will land on heads exactly 2 times. This is heads, heads, heads. That is more than 2 times. That is 3 times. That does not work. Head, head, tail. Did that work? That was 2 times. Circle it. That one works. Heads, tails, heads. Was that heads 2 times? Sure was. Heads, tails, tails. That's 2 tails. That does not work. Going over here, I have tails, heads, heads. That's heads 2 times. I have tail, head, tail. That's tail twice, not heads. Tail, tail, head. Nope. And tail, tail, tail. Nope. So 3 different times out of the total 1, 2, 3, 4, 5, 6, 7, 8 times. It has a probability of landing on heads exactly twice. Exactly is that key word there. Okay, now do your try it. Is it more likely that a coin flipped 3 times will land heads up exactly once, or will it land heads up exactly twice? So we just calculated it for heads up twice. What about heads up once? Pause the video, solve it. Okay, hopefully you guys solved it. So I want to figure out heads up exactly once. Heads, heads, nope. Heads, heads, nope. Heads, tails, tails. Well, heads, tails, heads, no. Heads, tails, tails. This one works. I'm going to underline it. I could have made another tree diagram. That probably would have been better, but I'm just going to use this one. Tails, heads, heads, nope, that's twice. Tails, heads, tails, that's once. This one works. Tails, tails, heads, that's once. That one works. And tails, 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 that doesn't work. So 1, 2, 3 are underlined out of the total of 8. So I just figured out that my alarm just went off, so my video stopped. I just figured out that the probability of these 2 things happening are exactly the same. Your example 3. We have, actually, we're not doing example 3. I completely forgot. We are not doing example 3. I want you guys just to go straight to your problems, and you are going to be doing questions 5 through 9 in your workbooks. I will see you all tomorrow. That's exciting. I hope you guys had a great Monday and an even better Tuesday, and I can't wait to see you guys all tomorrow, and we will have some fun. Have a great rest of your day, and I will see you all tomorrow. Yay!